Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So until now we have created a basic quantum program, and what we'll do today is we are going to work with Microsoft Q to create another program. So basically what we have created a program that can generate zeros or ones depending on the superposition of the qubit, and this is the code that we use to be able to do so. So what we are going to do today is pretty simple. We are going to create a random numbers generator in Q programming language. So basically how exactly the program will work is pretty simple. So first of all, we are going to define the highest number we want to generate with the variable max. So you can write down the number that you want. We are going to use a certain amount of bits to calculate the number of random bits that we need to generate. We are going to use the variable n bits to do so. And we will generate a random bit string that will have a length of n bits in this case. And after that, when all this would be done, we're going to run everything. So if our operation give us a number that is above the max that we have set it, what's going to happen is that nothing will be returned and the operation will happen again until we have a number that has an answer that is smaller or equal to the max number. So basically those are the basics of what we are going to do. So to be able to create this small little application, it's pretty simple. We need to work with some libraries. So basically the libraries that we are going to use are pretty simple. So we have our first libraries right here, as you can see them. So the first part of the code are actually libraries, and we will need to add some other libraries to our to our code. So pretty simple. The first library that we are going to add will be Quantum Maths. So open Microsoft Quantum Maths. Here we go. And the second library that we will need to add will be Microsoft Quantum Convert. So we are going to add it. So open Microsoft Quantum Convert. So basically, those are the two libraries that we will need. So as I said, to be able to create our application or our program, this is the libraries that we will need to work with. All right, so the next thing that we'll need is pretty simple. So we are going to add the few lines of code to be able to run everything. So what's gonna happen is that I will write down the code, and what you can do, guys, is simply, I'll write down the code, and then I'll explain this code basically. Alright, so the code that you guys need to add looks something like this. And now I will try to explain it step by step, basically what exactly I have wrote down. Alright, so the first thing that we need to do is define the operation. So in this case, I called it random number because this is the operation that we are going to use to generate random numbers. So here we are going to use the first part of this code. So indeed, the operation that we use are creating will repeatedly all the generated qubit operations to build a string of bits. So now that we have wrote our code, it's time to understand what we have wrote. So the first part will be calculating the required amount of bits that will be needed to express our integers to the max. So basically it's going to be here. So we have our max right here. To perform this, we will use the bit size. So the bit size right there. So this is a basically this is a function that is formed in Microsoft Quantum Maths library. So basically this function right here comes from the library right there. So to be able to perform it, we are going to use the library right here. So now that we have our operation right here, we use the repeat loop, so basically the loop right here, to generate different random numbers until it generates a number that is in the limits of what we have. So basically the repeat loop will, what it will do exactly is pretty simple. It will allow us to basically rerun the program until it reaches the right number. So basically a number that is smaller or equal to the max. Then after that, we'll have the for loop, and basically the for loop works pretty much the same way as in any other programming language. So we can, for example, think of Python. And finally, we will have variable outputs and bits that are mutable variables. So we have bits, we have other variables. In other words, these variables can change computation. So this is for the first part of the code right here. And basically what is missing right now, we have the other part of the code. Well, we have another little part of the code that is missing. And basically the part of the code that is missing is simply the output that we want to receive at the end. So basically, let's say we want to receive a message that will say generate the number generated, for example. And we will add the number generated at the end. So basically this is the core of our function right here. And what we did was simply added to the first part of our function right there. All right, so this is the last part of the code that we need. So basically, as always, we have our entry point right here. And from this entry point, we will have what we need to have our output. So basically, we will create another operation that will generate us int. So basically not unity, but int. This means that we want an actual answer that has information in it. In this case, we can set up our max to the number that we want. So in this case, our max is 35. I set it up to 35. You can set it up to, let's say, 100 or 75 or 50 or 25 or whatever you want. And I also decided to add a message right here. So basically, we are going to generate a random number that is lower than the max. So if we wanted to add a min, we can add a min as well. And that work with min and max, so we can have both of them inside of our output, so it's possible. And finally, what we want to return, we simply want to return the random, well, this function right, well, not function, but this operation right here that we worked with. So basically this operation right here, what it does, it's pretty simple. It will generate us a max number. So it will generate us a number that will be equal or lower than the max, because we asked it right there. As you can see, we want a number that is equal or lower than the max. So when it's all done, what we should receive as an output is pretty simple. So we should receive an output with all this code that will give us a number that is lower than the max, and we should receive a text also that will say generate a random number that is lower than the max. So let's try it out. So pretty simple. First of all, just open up your terminal and write down .NET run. So as always, what's gonna happen is that it will take a little bit of time. Okay, as you can see here, it generated a number that is 35. So it generated the max possible number in this case. So as you can see, it works pretty well. If you have some mistakes, sometimes it's just some basic typing mistakes, so we can check out for those mistakes as well. But usually for this type of code, it's pretty simple. So as you can see, it's pretty simple. Let me just recapitulate what we saw. So the first part of the code, well, the first part right here is the code that we had before. It's the test code. So basically we have our libraries right there, works pretty much as in Python. So we have our libraries. Then we have our first operation right here that works, well, that works with the qubits, and that will do superposition. So here we have our first operation that will generate, that we call generate qubit. Then we have our second operation right here that what it does is pretty simple. It will take numbers and it will generate a random number. So basically this is the operation that will generate the random number. And basically right here is the part of the code where we want to create our output. So in this case, we wanted the max, well, we wanted a certain max. So here we can simply enter the numbers that we want. For example, I wanted a max of 35. If I wanted to add a min, I could have done it also right here. And finally, I also wanted a message, but if I delete the message, it still will work. It will just not generate a message right here. It will simply generate a number. That's the main difference. So I hope you guys now received a brief introduction to QuantumQ. So as you can see, it works pretty much as any programming language. So if you know to program, it's basically the same logic. If not, there are plenty of, well, there is not that much resources that exist in this programming language, but if you want to learn programming, there are plenty of other programming languages that exist. But if you want to specialize in quantum computing, this is basically the programming language for this and to do so. So besides of that, you should have a basic understanding of quantum computing as well as Microsoft Q until now. So that's it for this class, guys, and see you all in our next class.